today I want to speak about hybridization and hybridized orbital. I started the carbon. As you know, the carbon atomic number is the 6, okay? And it has a 1s2, 2s2, 2p2. It is a ground state. It has a 2 electron in the first, 2 electrons second, and 2 electron in the third. We call it ground state. Okay? One electron can jump from here to here and become excited state. This process is called promotion. Okay? Then it becomes 1s2, 2s1, 2p3, and become this structure. We call this process is the promotion. Okay? Now we have it to. It is the first shell. I don't care about. We start with the last one shell. Okay, we have two types of the orbital. Is the S and P. S is the spherical, and it's the concave. Okay. Now they have a different shape. If I hybridize these 4 orbitals, we can make four the same shape and size orbital, which call sp3. Okay? sp3, then this carbon has sp3, okay? With the 4 the same bond length and must be same angle, okay? The angle must be 109.5 in this space. Okay, and if I draw the carbon in this case, I can draw like this 4 different space, specific. For example, it's the carbon. Okay, I can make with 3 hydrogen. One hydrogen is it has the 1s orbital, second hydrogen, and third hydrogen. Or I can make, for example, in the metal with 4th hydrogen. Or I can make with other carbon also with 2 sp3. It is sp3, and it is sp3 also with other carbon to make other sigma bond. Also, the 2 can have with hydrogen or other elements. Okay? All of the bonds are the sigma bond. The angle is 100.9. The carbon-hydrogen length is 110 picometer. Okay? And the carbon-carbon bond is around 154 picometer. Okay? This, it is for the all is the sigma and all is the sp3. Okay? It's 2 carbons. And the shape of the structure, geometric, is the tetrahedral. Okay. As you see, all hybridization. But if we have a ground state and promotion and excited state, but we change the hybridization for these 3, okay? And the 1p orbital is remained. In this case, we will have 3 sp2, we got from 1s and 2 p, 3 sp2, and 1 pz, 1p orbital. Okay, if I want to draw this one, okay, I have a carbon, okay, 1 sp2, other sp2, and third sp2, all are sp2. Again, and 1p orbital pz is remained here. Okay? Now I can add a hydrogen with these 2. I can draw other sp2, carbon. Again it is sp2, sp2, I add a hydrogen, and I have a one p orbital. Both of them is p orbital. Now, if overlap each other, this p orbital, make a pi bond, which is a pi bond. Okay? As you see, the main structure is it will be like this double bond. It will be pi. It is sigma, 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 sigma. The angle is 120. The shape is trigonal, planar. Okay? And carbon-hydrogen bond length will be a little smaller, 109. Why it is 110, it is 109? Because of the double bond has a higher electronegativity compared to the single bond. Okay. And the third group, if we hybridize one s with one p orbital, the shape will be 2 sp orbital and 2 p orbital. For example, p, y, and pz. Again, I draw it. Okay, I have a carbon with 2 sp, one with the hydrogen, other with the other carbon with sp. Okay. Second one also with hydrogen. I have a 2p orbital. One's the py, and the second one is the pz. It is a pz, and it is a pz. Okay. Now, if I overlap pz to each other, and I overlap two py with each other. Okay? In this case, we can say between two carbon, this is a 2 pi bond, and other is the sigma bond. Okay? They are sigma. Okay? And these two is the pi bond. The angle is 180 degrees, and the geometry is the linear, and the carbon-hydrogen length is 108. It's smaller than double bond, and it will be because triple bond has the highest the electronegativity compared to the double bond and the single bond. I hope it will be good second lecture. We will continue with you next time. I hope it will be good and have a good time.